Hello everyone, welcome back to Dprieto TV, and we are almost done with August. We are in the last week of August, but Prietology Season 5 Episode 2 is just getting started. Like I said, welcome back. Welcome back to Prietology. We are back with Season 5, Episode 2. We're back with Episode 2. The gas giant gang is what we will be talking about, the second half of the solar system. So yeah, we're excited to get into the Jupiter, Saturn, Uranus, and Neptune, and a bunch of other little miscellaneous things between all them we will talk about today. So yeah, I see no other reason to continue talking. Some quick announcements at the end. So yeah, let's start this episode and let's go over the key terms. Okay, so yeah, let's go over our key terms here in episode 2 of season 5. The gas giant gang, like I said, we're talking about the second half of the solar system. So, wrong thing. We have Jupiter, Jupiter's moons, which we'll talk about. There's another name for them. Saturn, Cassini, Titan, Uranus, and Neptune. Some interesting terms for episode 2, so yeah, let's get started. Alright, let's get this show under the road. Jupiter, our first term, the 5th closest planet to the Sun, and the largest in the solar system. It is huge. It is ginormous. People don't understand it's a ginormous gas giant. It is so big. It's unbelievably big. It's probably like a tenth of what the size of the Sun is, which in Sun terms is huge. It's almost made entirely of hydrogen and a little bit of helium, but mostly hydrogen, so it's this close to tripping into a star. If it was just a little bit bigger, it would be its own star, and Mars and Saturn would they wouldn't vaporize. Mars would be much hotter. We would be much hotter. Saturn would be much hotter as well. Uranus and Neptune. Yeah, it would have changed everything if Jupiter was a star. It was only this much off. It has 63 moons. I remember in the last episode when we were talking about Mars and Earth, them only having 1 moon with the Earth and 2 moons with Mars. This one has 63. A lot of our gas giants have a lot of moons. It has 63 moons and moonlets, which moonlets are not the moons of moons, which I thought was before this episode. But they're actually small little bits of like anything, like rocks, like a little small thing that orbit it. Not exactly like a terrestrial moon, not that big, but little moonlets. So like, let's say little asteroids that orbit it somehow, not in a ring, but just asteroids in general that go outside the orbit of the ring. It spins, its like spin on its axis is very quick. The days on Jupiter are only 10 hours. They are much shorter than here, less than half our day here. Our day here is only 24, theirs is 10. Only 10 days with it spinning, and with that spin, it creates very, 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 very high winds in the atmosphere, the cloud tops of the atmosphere, that go to about 260 miles an hour, which are screaming fast. And yeah, very, very fast winds with that very, very fast spinning. As we all know, if you've seen a picture of Jupiter, like right there, that big old spot right there, that's the great red spot everyone knows about. That storm that has been there since the 1600s. A violent tornado, hurricane, just mess. It's just a mess. It's just a giant storm in the middle of it. It's about the width of 2 Earths. So it's amazing. So essentially going around the Earth once is the width of the Great Red Spot. Fun fact, it's 318 times more heavy than the Earth. It is very heavy. Like I said, it's so massive. It's unbelievably massive. It's unthinkably massive. It's this close to becoming a star, like I said. Let's move on to the next term. Alright, Jupiter's moons is our next one. We talked about Jupiter. The moons, this is where it gets interesting. The moons, when we talk about the moons of these planets, they're going to get interesting. They include the 63 moons of Jupiter, like I said last time, and are kind of like their own little mini solar system. There's so many, it's so massive. The Jupiter, like I said, acts as its own star, and it has its little moons circulating it. That's what makes Jupiter such an interesting planet, that each moon is so different from the other one. So yeah, let's talk about them. The biggest, most known ones, there are 4 that are called the Jovian moons, considering I forget what it's about, but I think, I'm trying to remember. I think Jupiter and Jovia, or Jovine, I forget the name of the Greek god, but anyway, they're called the Jovian moons. They are, let's put a list down here, Ganymede, Callisto, Europa, and Io, or Io, I don't know how you say it. So yeah, Ganymede, Io, Callisto, and Europa. Let's talk about each of them. Io is the most volcanic place in the solar system. It's like that volcano place from Star Wars, but not that volcanic. It's the most volcanic place in the solar system due not to like volcanoes underneath or like rumbling lava or earthquakes or anything. It's actually due to friction. Yeah, imagine that. Friction. Why? Let me explain. Io's gravity, so imagine you have Io right here. Gravity around it, its own magnetic field and force field. Jupiter's gravity, on the other hand, is so massive that it just scrapes against Io and warps it, and it's under intense gravity from Jupiter, and its gravity just scrapes it and like melts it and like wobbles it around. It like compacts it and stretches it, so all the kinetic energy of it being stretched causes the rocks to heat up and eventually melt, and then lava comes out and geysers and stuff. Yeah. That is how Io is volcanic. It's under so much pressure from its gravity, from Jupiter's gravity, that just scrapes against it and it makes it volcanic. Interesting. Europa, on the other hand, is one that can actually sustain life. It's covered in solid ice, like solid water ice, but it could have life-sustaining salt water underneath all that ice. So who knows? That's maybe something for the future to find out. Ganymede, on the other hand, there's not really anything special about Ganymede other than it's the only moon with a magnetic field. Fun fact. That's actually, out of all the 63 moons, 62 of them don't. Ganymede does. So that's interesting. Callisto, on the other hand, kind of dead. In a nutshell, yeah, it's kind of dead. Just a dead planet, kind of like Mars. How it's just barren with nothing, just rocks, no atmosphere, tons of craters and cracks and everything. Yeah, dead, old, wrinkly planet. I mean, not planet, a moon. Fun fact. Like I said in a while back when we were going over the key terms, these moons are also called the Galilean moons. And in 1610, Galileo, with these moons, he proved that the Earth wasn't the center of the universe. With his discovery of Jupiter and the Jupiter moons, he proved that the Earth wasn't the center of the universe / the solar system. Because back then everyone thought the Earth was the center, the sun orbited it, and all the planets did. But no, sun orbits it. That is correct. Alright, next term. Alright, on to term number 3 here. We're halfway, but it's 7 terms, so this is exactly not a half. But anyway, let's talk about the most, in my opinion, my favorite planet, and the most beautiful of them all, Saturn. The ringed planet. 6th closest to the sun, but surprisingly, only has a gravity 90% more, 0.9 times the Earth's gravity. So, not that much, which is kind of surprising. It has at least 60 moons, so 60 plus moons and moonlets, like we talked about little other things that orbit it. And obviously they're still finding some, but so far we have found 60 of them, which is still a large amount for a planet. And considering it's kind of big, so yeah. Has very beautiful looking atmosphere, perfect shades of sometimes green, of blue, of a nice yellow, kind of like a tan-ish. And obviously known for its rings. Beautiful rings that surround it. But surprisingly, their rings are about, I'm going to have to say this number right, 1,550,000 miles wide. So, ginormous. But they're only 164 feet thin. So, astronomically or planetarily, or in this concept of Saturn, they are incredibly thin. They are super thin compared to how big Saturn is and how wide they are, but they are incredibly thin, about 20 meters thin. And the rings are made of rocks, so like asteroids, ice, water ice, methane ice, hydrogen ice that freezes in the vacuum of space, and dust. Not like dust that you find in your room or a dust bunny, like crushed up rock in the form of dust. So rock, ice, and dust make up its rings. People believe, or not people, scientists rather believe, that Saturn actually has an ocean. It's essentially under all that cloud layer and all those violent winds, which we'll talk about in a bit, has an ocean of liquid hydrogen. Of course, it's so far away from the sun. It's at a temperature where hydrogen is able to freeze. Well, not freeze, but go from a gas to a liquid. If you want to learn about gases and liquids, go watch season 1 of Prietology. But it's at a distance far enough so that the hydrogen in it is able to go to liquid form because it's so far. So it could just be an ocean of liquid hydrogen like the Earth, but essentially no land. And it could have a core of solid hydrogen. Yeah. There's a lot of stuff we haven't discovered about Saturn yet. That's what makes it such an interesting planet, and we'll talk about more about it later. Fun fact! The cloud tops and planets are essentially like the tops of the clouds, so like the atmospheric layer, like the air in it, so like the cloud tops, like, you know, where the clouds are above those clouds, winds can get up to 1,243 miles an hour. Wow. Try saying this. A lot of people actually struggle to say this on the first time, but this is actually really cool, interesting. Cassini hygens. They're actually a pair of space probes. We've talked about Saturn actually for a bit. They're a pair of space probes that went to investigate the wonders of Saturn. Cassini and hygens. They're two different space probes, but people usually put them in the same word because they were part of the same mission. Cassini went to Saturn and went around the planet 74 times, and recently, in the past couple of years, went 20 dives between Saturn and its rings and collected a ton of information, while Huygens, which is a little smaller space probe, was sent to investigate the surface of Titan, which we'll talk about in a bit. They're the first ever probes to orbit Saturn. It studied its rings, magnetic field, atmosphere, and 7 of its moons. Very accomplished space probes. The mission ended, unfortunately, in September 15th of 2017. It was been gone for a while, and it started in 1997. So a long time ago. And yeah, let's talk about fun facts. It was named after astronomers. These two probes were named after astronomers, Giovanni Domenico Cassini and Christian Huygens. Cassini discovered Cassini's gap, which is the space between Saturn and its rings. That's why Cassini, in its last couple of months of mission, it went between its rings and just studied a bunch of information. That's why it's called Cassini's gap. And Huygens discovered Titan, so it was only appropriate that Huygens got to go to Titan. So yeah, fun fact about each of those things. So yeah, let's keep talking about Saturn in a pretty interesting term. This is by far a very, very interesting planet. Saturn's largest moon, Titan, named after the Titans in Greek mythology, the weird giant beings that would torment the Earth, something like that. So yeah, second largest moon in the solar system. Ganymede is the largest moon in the solar system. Fun fact, we talked about it a while ago. So it's only 2% less than Ganymede, and bigger than Mercury. It's bigger than Mercury, even a planet. Mercury's pretty small for a planet. And it's bigger than Mercury, fun fact, and it's Saturn's largest moon with a diameter of 3,200 miles. It is huge. A 124-mile deep haze covers its surface. It's pretty huge, but it's all hazy. It's methane. It's a methane haze that covers it. It's a 124 thick, deep haze, and it's the only moon in the solar system with a permanent, you heard me say that, permanent atmosphere, covering it in a reddish methane haze. It's so thick that you could literally swim in it. Literally, like, imagine swimming in a pool or in a lake. You could literally swim through the atmosphere of Titan. It is so thick. Obviously, don't breathe it because methane. You can't breathe methane. Huygens, we just talked about Huygens, we just talked about in the Cassini Huygens. Huygens reported that when it went into Titan, it has a surface, lots of craters, even sand dunes, many liquid methane lakes, and weather and seasons. Does this sound familiar? It should. It's a lot like Earth. This could be a life-sustaining planet. Huygens just scratched the surface. Well, it didn't scratch the surface. It went pretty deep underneath. But still, there's a lot about Titan that we haven't learned yet. But Huygens discovered a lot about it. Obviously, we don't have methane lakes, but we have lakes. We have some craters. We have sand dunes. We have weather. We have seasons. So Titan could be a gold mine of scientific information we haven't seen yet. Fun fact, the surface pressure, remember how I said it's so thick you could swim through it? The surface pressure on Titan would be a lot like being at the bottom of a swimming pool. That's how much the pressure is, but it can be super crushing because 124 feet of water, that's a lot. And still, it's so thick, the atmosphere, like you could literally swim in it. So just sit at the bottom, try being at the bottom of your pool and seeing how that pressure's that would be the surface. That would be the surface pressure on Titan. So yeah, 2 more terms to go. Alright, where's my marker? We are almost done with the solar system. We got 2 planets left, and then after that we're going to be going a little bit beyond the solar system in the next episode, but we'll talk about that at the end. Uranus, not Uranus. Ha ha. Uranus is how it's actually pronounced. It's the 7th closest planet to the sun. It's pretty far. 27 moons and moonlets. It's starting to decrease a little bit. Jupiter has the most, then Saturn, then Uranus, then Neptune. About an average temperature, as you know, the farther we go from the sun, the colder it gets. 346 degrees Fahrenheit average temperature, negative 346 degrees Fahrenheit average temperature. It is freezing cold, nearing absolute zero. It is absolutely freezing there. You would freeze in an instant the moment you step in Uranus, considering if you even get there in the first place. Long ago, not in a galaxy far, far away in our solar system, a collision knocked it sideways. So imagine Uranus. Where's my Uranus? It's up there, but I'm not going to get it. So let me get a sphere. Alright, I have this little glass ball. I don't know if you can see it right, but a little glass ball. Long ago, let's say it spins like this. The glass ball of Uranus spins like this, like a normal planet. But long ago, it got hit sideways, and now it's spinning like this, but now it's tilted like this, and it spins like this on its axis sideways. Because of its sideways spin, how it spins like this, the poles, or the both sides of it, face the Earth for 21 years, and then 21 years in total darkness. So do the math, a full year on Uranus is 41 Earth years. So yeah, pretty interesting. Because it only spins sideways, imagine spending 21 years in direct sunlight and then 21 years in absolute darkness with nothing. Absolutely nothing, because you're literally facing the vacuum of space where there is nothing there. On Uranus, there are very large storms, and all of these gas giants, there's lots of winds and storms. There's big storms that shoot clouds of crystalline methane, so methane in its crystal solid form, at high speeds of around 260 miles an hour. Screaming fast, shooting along the atmosphere, just like shooting along the atmosphere, 260 mile an hour clouds, imagine that, and they just rain crystalline methane. And sometimes, if it's so much pressure, because it's made of methane, it's so much pressure that it forms diamonds, because methane is carbon-based, and if those pressures high enough, it can make diamonds. So sometimes it can literally rain diamonds, which would be pretty cool, but kind of painful, because diamonds are very sharp, so they just go in your face and that would really hurt. Fun fact, it has rings, if you haven't never seen a picture of Uranus, so to our little model, just add rings, along with 4 other planets. Fun fact, if you haven't seen. All the gas giants that we have rings. All of them. Jupiter, Saturn, Uranus, and Neptune. All of them have rings. That is a very interesting fact. Even Saturn obviously has rings. Jupiter's a bit smaller, a bit faint, not that easy to see. Saturn obviously has rings. Uranus, if you haven't seen it before, does have rings, but sideways like this, along with the spin, much thinner. And Neptune, obviously, well, not obviously, but sometimes they're visible, but not that visible, but it has very thin rings, kind of like Jupiter. Alright, let's get to our final term, the final planet of our solar system. Alright, final term of episode 2, the farthest, the coldest, with an average temperature of 336 degrees Celsius, goes to Neptune, the farthest last planet in our solar system, with 13 moons and counting. Its pure white ammonia clouds move super quickly in the solar system atmosphere, not the solar system, its atmosphere, 1,550 miles an hour, incredibly fast, freezing cold, causing the highest ever winds in the atmosphere. In the solar system. The highest winds you can find anywhere, even faster than the screaming fast ones of Uranus, Saturn, Jupiter, Mercury, Venus, Earth, and Mars. It's faster than all of those. It's the highest in the solar system. Under the atmosphere, which is made of ammonia and methane, it has a boiling ocean of liquid methane that can create diamonds like Uranus, except Uranus's diamonds are made from the atmosphere of those ammonia, those crystal methylene clouds. Crystalline methane clouds, those ones that shoot super fast and make under pressure. Its boiling ocean of methane can make diamonds. It's the first ever planet in the solar system, the only to not be found by a telescope and an astronomer, but to be found by mathematical calculations. It was found, oh, I forget who it was founded by, but yeah, it was founded by mathematical calculations. I'm guessing they observed something was pulling gravity of something, gravitational, something should they essentially decided like, oh, there should be a planet there, so calculate it, and you find Neptune. For 20 years, a giant tornado in, I forget where, I think along its equator somewhere, called the Great Dark Spot. This sounds like another one, the Great Red Spot on Jupiter, but this one is called the Great Dark Spot. Existed in the southern hemisphere. That's where it resided for 20 years. It's gone now, compared to the Great Red Spot, which is still here after even 400 years. And with Neptune, its pal, Uranus, both of them are considered the ice giants, considering they are also part of the gas giant gang along with Jupiter and Saturn. Neptune and Uranus get a special little membership thing. They're the ice giants, the only two that we have in the solar system. Fun fact about Neptune, our final fun fact of the day, the largest moon of Neptune is called Triton, not Titan. Titan is part of Saturn. Triton is named after the son of the Greek god Poseidon, I believe so. Triton is the coldest place in the solar system, even colder than Neptune itself. It's freezing cold, the coldest place in the solar system. It's the largest moon of Neptune, and one cool thing about it is that it orbits in the opposite direction of Neptune's spin. So say Neptune is spinning this way, Triton would orbit this way. It would orbit the opposite direction of Neptune's spin. We are done. We have gone over our 7 terms, and yeah, pretty good, interesting. We finished the solar system. So yeah, let's go for announcements. Whew, what an interesting my stuff fell. What an interesting episode. That caught me off guard for a second. 7 terms, we finished the solar system. So yeah, some announcements, really quick ones. I'm thinking about introducing a new gaming series at the end of the year. It's going to be the last video before the Dprieto Christmas special, which is essentially our finale of the year. So it's the video just before that. I'm thinking of doing, I don't know honestly, it's just whatever you guys want. So if you want, you can put some comments under this video or comments under any of my videos. Or I'm going to make a community tab post after I finish editing this video that I'm doing right now. Hi, editing me. There's going to be a community tab post. If you want, I'll put that there. Shoot your ideas. Next video coming on to you on September 10th. Cuphead gameplay number 8. We are back with Cuphead, back on Inkwell Isle. We're almost done with the second isle, I believe. You haven't done it in a while. So yeah, 8th gameplay of Cuphead coming to you on September 10th. Don't forget that. Stay tuned for it. The next episode of Prietology, coming soon after Cuphead, will be about beyond our solar system. So essentially what I call the Transneptunian. Transneptunian means beyond Neptune. So just beyond Neptune. So Pluto, you're wondering, hey, what about Pluto? We haven't talked about it yet. Well, it's not part of the solar system, unfortunately. But Pluto, Halley's Comet, the Kuiper Belt, the Oort Cloud, Eris. We still have a lot of things to talk about just neighboring our solar system. Then after that, we'll start getting into galaxies, stars, constellations, black holes. Cool stuff about space that's well beyond our solar system. So yeah, that's all for next episode, episode 3. So yeah, get excited for that. But in the meantime, thank you for watching. I will see you in 2 weeks for Cuphead number 8 on September 10th. See ya, and remote.